Hello everyone, welcome back. This is Double2. Now this video covers topics about convergence properties of sequences. We have seen 3 videos about limit of sequences, and now convergence properties of sequence. First thing is, what does it mean, convergence? Which is, we have the following factors about monotonic sequence. Because if a monotonic sequence is unbounded, then it diverges because there is no limit. It is open. Yes, there is no limit in its lower least upper bound, or there is no lower bound in upper bound. Then it diverge to any number which is unknown. And if a monotonic sequence is bounded, then it converges, which means it has the limits, which is the upper bound and lower bounds. We know when the numbers or the value of n's in the sequence will become large, the value or the sequence will proceed to one number. That will be between the limits. It will be upper bound or lower bound, but it is bounded on that value. If it is, yes, when we say converges, when we say the sequence is a convergent sequence, it is bounded. There are 2 options in the convergent when the monotonic sequence is bounded. The first one is, if it is bounded and increasing, then it converges to the least upper bound of the sequence, which means when it is bounded, our sequence is bounded and increasing, which means it converges to the least upper bound. Yes, because we have a lot of upper bounds, but we know the least upper bounds, because when we enter different values for the variable, which will be x or n in the sequence, then that sequences converges to the least upper bound when it is an increasing. The second one is, if it is bounded and decreasing, then it converges to the greatest lower bound of the sequence. When we say the value is bounded, then decreasing, which means 5, 4, 3, 2, 1. If it is just like this, decreasing, then the value converges to the greatest lower bound of the sequence, which is, let me say, 1 is the lower bound, then it's not only the lower bound, it's the greatest lower bound. So when it's decreasing and the greatest lower bound is 1, then the monotonic sequence converges to 1 because it is a decreasing. This is all about divergent and convergent. We have a clear definition or explanation about convergence. There are 2 things in convergent. It is bounded and increasing, it will converge to least upper bound, and bounded and decreasing, then the sequence is converged, or the values converge to the greatest lower bound of the sequence. Okay, show that the sequence n plus 1 over to n plus 3 converges, which is n plus 1. When we expand the sequence, n plus 1 over to n plus 3 equals to 1 over n minus 1 over 2 into to n plus 3, which means this value is increasing, the sequence is increasing, then 1 over n minus 1 over 2 n plus 3 is increasing, the increased value, with when we insert the value n, yes, 1, because it is a natural number starts from 1, so it will be 1 plus 1 is equals to 2, and this is 1 times 2 plus 3 is equals to 5, 2 over 5. less than or equals to n plus 1 over 2n plus 3. Less than or equals to 1 over 2. 1 over 2 means when we enter or remove n as a common value from this function, it will be 1 over, this will be it will be 1 plus 1 over n. Secafral over n means when we n which is 2, because 2n over n equals to 2 plus 3 over n. N is divided by n is equals to 1, and when n goes to becoming a large number, which is 1000 millions, those value will approach or converges to 0. Yes, this value also converges to 0, which means it is only 1 over 2. So finally the value converges to this value, and it is between those 2 over 5 less than or equals to n plus 1 over 2n plus 3 less than 1 over 2 for all natural number. So it is bounded and monotonic, and hence it converges, because as we have seen, limits n plus 1 over 2n plus 3, which means as I told you this in this as I show you in this, it is limit n approaches to infinity, it will be 1 over 2. So n plus 1 over 2n plus 3 converges to the least upper bound of the sequence, because when we in the previous slide we have seen when the sequence converges, it is bounded, monotonic and bounded, and converges to the monotonic is increasing, the fact that the sequence is increasing, it is converges to the least upper bound. And when the sequence is decreasing, it converges to the greatest lower bound of the sequence. So we seen this function is increasing, this sequence is increasing and converges to the least upper bound of the sequence, which is 1 over 2. And thank you everyone. Don't forget to subscribe. If you have any comments and suggestions, you can write down on comment section, and please share for your friends if you love the video, and yes, subscribe.